Assalamu alaikum. Good afternoon, dear students of Standard 10. How are you all? Hope you all are fine by the grace of Almighty Allah. So, welcome back to my physics class. Dear students, I am going to explain some mathematical problems from chapter 10 of your physics book. So, give your attention fully to understand the mathematical problems. Question number 1. What is the magnitude of electric field at a distance of 10 meters for 5 coulomb charge? So here the field creating charge is 5 coulomb, and at a distance 10 meters from that 5 coulomb charge you have to calculate the electric field intensity. For doing this mathematical problem, we will require the formula E equal to K into Q by R square. Here Q equal to 5 coulomb, R equal to 10 meters, and K, that is the constant, that is known as Coulomb's constant, equal to 9 into 10 to the power 9 Newton meter square per Coulomb square. Now you just put down the value in this equation, that is equal to K into Q by R square. Here Q equal to K, that is 9 into 10 to the power 9, Q equal to 5 coulomb and 10 square. So you get the value 4.5 into 10 to the power 9 Newton per Coulomb. Have you understood the math? Very simple math, isn't it? Now there is another simple math for you. A charge of 3 coulomb is experiencing a force of 10 Newton. What is the electric field? So for doing this math, you will require the formula F equal to QE. So you have to find out E equal to what? So E equal to F by Q. Here given F equal to 10 Newton, then Q equal to 3 coulomb. So put the value in this equation. You get 10 by 3, that is equal to 3.33 Newton per Coulomb. Very simple math. This type of mathematical problems frequently comes as your MCQ question. Also it can come as C number question. Let's look another problem. Two charges of 5 coulomb and plus 3 coulomb are placed at a distance of 1 meter. Now a third charge plus Q is placed in between, here will be N, between them. While will it not feel any force? So here I have drawn the figure of this question, of this mathematical problem. Look, 5 coulomb charge and 3 coulomb charge are placed at a distance 1 meter from each other, and you will place a charge plus Q coulomb between the joining line, joining the charges. So on this line plus Q charge is placed where it will not feel any force, and the position of plus Q charge is at x meter from 5 coulomb charge, and obviously it will be 1 minus x meter because the total distance is 1 meter. So when plus Q charge is placed at this position, then an interesting matter will be happen. That is, plus 5 coulomb charge will repel plus Q coulomb charge towards the right direction, and plus 3 coulomb charge will repel plus Q coulomb charge towards the left direction. So, and these two forces will be equal. That's why equal force when acted from both sides, so there will be created a balanced position, and the plus Q charge will not feel any force. So look, so the force between 5 coulomb charge and Q coulomb charge is 5Q by x square, and here will be another K constant. Here is also a constant missing, and K into plus 3Q by 1 minus x square. Then K from both sides will be cancelled. So look here, K into 5 plus 5 into Q divided by x square, that is the distance from plus 5 between plus 5 coulomb and Q charge, and K into 3Q by 1 minus x square, that is the distance between 3 coulomb charge and plus q coulomb charge. So k will be cancelled from both sides. So then remain 5 into 1 minus x whole square equal to 3x square. So it will be, by calculating, we can get 2x cube minus 10x plus 5 equal to 0. Now we can get the value of x by using binomial equation. Okay, 10, and it will be equal to x equal to 10 plus minus root over 100 minus 40 divided by 4. The formula is you can see from your higher mathematics or general mathematics book. I think in your mathematics book you can get this formula. Okay, the formula is x equal to minus b plus minus root over b square minus 4ac divided by twice a. Okay, the formula is minus b plus minus root b square minus 4ac divided by twice a. So here the value of x equal to, if x can be, if we use plus sign, then x can be 4.435 or meter, or if we consider minus sign, then x, the value of x will be 0.565. So you have to think which distance you will take. This one or that one. You have to think one thing, that is the distance between 5 coulomb charge and plus 3 coulomb charge is what? 1 meter. But here x equal to 4.435. So that is out of this region, out of this distance. But here x equal to 0.565. So this is in between 1 meter. So obviously x, that means the position of plus q charge, will be 0.565 meter from plus 5 coulomb charge. So as the value of x will be between 0 and 1, so the value of x must be 0.565. That means the plus q charge is placed at a distance of 0.565 meter from the plus 5 coulomb charge. That is the answer. Now problem number 4. Look here, at the point A, a charge plus 40 coulomb charge is placed, and at point B the 20 plus 20 coulomb charge is placed. So here you have to find out the amount of force between the charge A and B. And in B number, if a unit positive charge is placed at the point C, that means at point C if you have to place a unit positive charge, for which charge the intensity at C will be greater. For which charge the intensity at C will be greater? Explain mathematically. So at first do A number, find the amount of force between the charge A and B. A and B both are positively charged object, so the force between them must be repulsive force, that is Coulomb's force, and we can calculate it by using Coulomb's law. So here Q1 equal to positive 40 coulomb charge, Q2 equal to plus 20 coulomb charge, distance equal to, look, C point, the distance between for A and B is not given, but it is given that C is situated at distance 6 meter from B and at distance 18 meter from A. So the distance between the two charges must be what? 24 meter. That is 18 centimeter plus 6 centimeter. Sorry, 24 centimeter. That is equal to 0.24 meter. Now calculate the Coulomb force. You know, F equal to C into Q1 Q2 by R square by D square. So C equal to 9 into 10 to the power 9 for Q1 equal to 40, Q2 equal to 20 divided by 0.24 square meter, and it comes 1.25 into 10 to the power 14 Newton. That is the answer. Now for D number, look, the charge at point A equal to plus 40 coulomb, the charge at B equal to plus 20 coulomb, the charge at point C equal to plus 1 coulomb. It is given in the question that an unit positive charge is placed at point C. Distance between A and C is 18 centimeter, that is 0.18 meter, and distance between B and C is D2, 6 centimeter, that is 0.06 meter. C equal to 9 into 10 to the power 9 Newton meter square per coulomb square. So we have to show that intensity for which charge at point C is greater. So intensity at point C for the charge placed on A is, if an unit positive charge is placed at point C, then the charge will experience a force. That means an electric field intensity can be calculated for that unit positive charge. So E1 equal to C into Q1 by D1, because here the field creating charge is Q1. 9 into 10 to the power 9 into 40 by 0.18 meter square. What comes? 1.11 into 10 to the power 30 Newton per coulomb. Now we will find out the intensity at point C for the charge at point B. Very easy. E2 equal to C into, it will be Q2. So E2 equal to C into Q2 by D2. 9 into 10 to the power 9, that is Coulomb's constant, the value of C, into 20 by 0.06 meter square, and it comes 5 into 10 to the power 30 Newton per coulomb. So which one is greater? Obviously this one, 5 into 10 to the power 30. This one is greater. So the intensity at point C for the charge at point B is greater. That means E2 is greater than E1. So these type of creative questions can come as in your SSC examination, and you should practice. I think all of you have test paper of previous years, so you should practice by using your test paper. Then the problem in mathematical solution will be overcome. So dear students, today up to this, thank you for watching my content attentively. Goodbye.